That's the way you want to see a part fail.
Today, we're diving into Obsidian PA6+CF, a carbon fiber reinforced nylon filament from IDEX Tech, designed as a cost-effective alternative to Markforged Onyx filament. It's strong, it's stiff, it's lightweight, and it's super functional. But did we mention beautiful? If you know Markforged, you know what I'm talking about. So in this video, we're going to walk through what it is, where it's used, how it prints, and why it might be the best kept secret in carbon fiber nylon 3D printing. And of course, you can buy some today at visionminer.com/materials. We are a business and we are to help you out with all this awesome 3D printing and 3D scanning stuff. So give us a call or shoot us an email. We're always here to help. So what is Obsidian PA6+CF? What are we working with here? Obsidian is a carbon fiber reinforced composite-based PA6, also known as nylon 6, one of the most common engineering thermoplastics in the world. Obsidian is blended with less than 20% high modulus carbon fiber, giving it a matte black finish and massively boosting its stiffness and, of course, dimensional stability. It's essentially 3DX Tech's answer to Markforged Onyx, but at 30 to 40% lower cost per kilo with open platform compatibility. So there's no proprietary printers or slicers that you need to print this stuff. Onyx is priced around 190 to 200 for an 800cc spool, whereas Obsidian is available for about 130 per kilo. So that's a savings of really over 30%, making it a much more cost-effective alternative without compromising the quality. But here's the kicker. While Onyx is locked into the Markforged system, Obsidian runs great on everything from your Bambu to the Vision 22 IDEX, giving you full freedom to dial in profiles and actually optimize your machine and part geometry. It's basically like getting a Markforged quality print in carbon fiber nylon without paying the brand tax. Now, where it really stands out for all you guys out there that have Markforged printers, it's a drop-in replacement. It's totally compatible with all the Markforged printers, including the Onyx One, Onyx Pro, Mark II, X3, X5, X7, and quite possibly the FX series. No changes to print settings or anything is required. You literally just use this stuff instead of the stuff from Markforged. So here's the actual spool, of course, packed very nicely. And yeah, this is what you get. It's a slightly different sized box. So whether you're using a Markforged printer or any open platform desktop FDM printer, Obsidian offers a versatile and economical situation for making the most beautiful possible parts in CF-nylon. So where is it used? Let's talk about some real-world applications. So Obsidian and carbon-filled nylons in general are used a lot in aerospace, automotive, robotics is a huge one, industrial tooling, and much, much, much more. So here's where it can really shine. Motorsports and racing teams use PACF composites for custom brackets, sensor housings, and lightweight panels that can survive vibration or splashes of fuel and heat. Now, robotics companies use it for grippers, soft jaws, and end-of-arm tooling, where rigidity and weight savings both can really matter a lot. In manufacturing, it's used to print jigs and fixtures and alignment tools that would otherwise be machined in aluminum and take much more time and be much more expensive. Now, aerospace engineers use carbon-filled nylons for ducting, mounts, interior components, because they hold their shape under thermal stress. They don't creep nearly as much as regular unfilled nylon. In automotive, it's used for under-the-hood brackets, clips, enclosures, especially anywhere that fuel or oil or hydrocarbon exposure is a big factor, like in any engine bay. Civil engineers and military R&D teams have printed field-use components, things like drone chassis, this huge one, mounts of all sorts, enclosures for ruggedized electronics. Obsidian is especially popular with teams running open source printers on everything from the Bambus, the Prusas, even our 22 IDEX, where you can fully tune the parameters to bring out all its performance. Technical data, the TDS, let's hit the specs. Here's what you get, and here's what Obsidian brings to the table. You got a tensile strength of 44 megapascals. You get a tensile modulus of 3.5 gigapascals, a flexural strength of 75 megapascals, a flexural modulus of 3.8 gigapascals, a tensile elongation at break of 11%, a heat deflection temperature at 0.45 MPa of 147 Celsius, with a surface resistivity of greater than 10 to the 9th ohms, so it's very insulating, the density of 1.2 grams per cubic millimeter, and no published IZOD impact, but User feedback suggests that it's stiffer but more brittle than the actual Onyx material from Markforged. So you're basically getting better stiffness, higher strength, and really good heat resistance, but at the cost of a little bit of toughness. This stuff is a little more rigid, but it might snap before it bends, and Cole is going to demonstrate all of that later in this video. But first, what makes Obsidian even more special? Let's break down why it really stands out. The biggest thing is the cost-effective carbon performance, right? You get the rigidity and strength of carbon fiber reinforcement and the beauty of a Markforged print for about a third less cost than Onyx. The professional surface quality, the matte black finish absolutely looks incredible. It's very clean, very functional, and very serious, especially for customer-facing prototypes. That's where we're seeing a ton of use. It's also got super low warp and shrink thanks to the carbon fiber, so it holds very tight tolerances and stays flat even on larger parts. It's also got oil and fuel resistance. Like most nylons, it's resistant to hydrocarbons, so it's perfect for parts that are near engines or lubricants of any kind. It's also got really broad compatibility, so it works on open platform printers, no locked slicers, no DRM, just filament and settings. Plus, unlike some of the cheaper PA/CF blends out there, this one actually holds dimensional tolerances, which is key when you're doing threaded assemblies or mating parts together. So, how does it print on the 22 IDEX? We've been running Obsidian for quite a while and the results are solid. The biggest thing we've noticed is you get very clean layers. The walls and surfaces are just absolutely phenomenal, just like you would see on a Markforged printer. It's got good bridging and overhang performance, and you get very stiff parts. It is definitely a little bit stiffer than the Onyx that I've felt in a lot of situations. Just make sure you're drying the filament because it is very hygroscopic, and if you don't dry it properly, your parts are going to bubble, ooze, and cause delamination or just poor surface finish, etc. But when you've dried it and tuned it in, it prints like an absolute dream. So what do you need to print Onyx? The setup we recommend, the minimum specs is about 265 to 285 on the nozzle, Celsius. The bed temperature about 90 to 110 Celsius, chamber temperature about 60 to 70 Celsius, and that's optional, but it does help a lot. With any nylons, it's going to reduce warping and everything. Definitely use a hardened steel nozzle. This filament is going to chew through your brass because of the carbon fiber, and definitely dry it for at least 4 hours at 90°C. If you can, use a vacuum oven or at least a vacuum chamber, especially with nylon, it absorbs a lot of moisture. So if you can get that vacuum chamber going in there, it really helps just reduce the boiling point of the moisture and release it into the atmosphere at that vacuum. And if you do skip drying, you will definitely regret it. The material absorbs moisture very fast, and wet nylon prints are brittle and stringy and weak, and you just want to avoid it. If you're interested in the solutions that we provide, you can go to visionminer.com/drykit. It's definitely highly recommended for really just about any material, but the high temp and nylons, polycarbonates, everything else like that, we provide all that stuff and we help you with it. So check that out if you want. That's the rundown for Obsidian PA6+CF, a no-nonsense carbon-reinforced nylon that punches way above its price point up into Markforged territory. So if you want carbon fiber stiffness without being locked into a proprietary ecosystem, really this is best for the guys with Markforged to save money, and then the guys that want the most beautiful carbon fiber prints that you can get. On the 22 IDEX, it gives you full control, great performance, and prints that look really great and are super functional. So let's hand it off to Cole and put some real stress tests onto this material. We're going to be burning and breaking and twisting and all that. So let's see what it's really made of.
The Markforged drop-in replacement, Obsidian carbon fiber nylon, a PA6 to be exact. We're going to put it through its paces and see how it stacks up. Not only being a drop-in replacement for Markforged and a drop-in engineering material, but also the fact that it prints absolutely beautifully for end-use parts. So, in Vision Miner tradition, we are going to break this by hand. Even though it won't really give us any usable number data, we're going to do it for mouthfeel. There we go. Okay, more flexible than I thought it would be. Before we go over to the testing machine and the torsion tests, let's get to the part that's fun to watch, shall we? Fire time. Full power, 5 seconds, 1 inch away with propane. We're going to both see how it burns, but I also want to time how long it takes for it to self-extinguish, if it will, and how long it takes to stop smoking. I need a stopwatch. There. ASMR. It's a goose. Begin. It dripped very quickly. Interesting to do this after PSU, because with the PSU, you can tell it degrades. It doesn't necessarily melt the same way. And this is, woohoo, this is just molten melted. I'm looking to see how long it takes for the smoke to stop, not necessarily it stiffen or anything like that. .93. I need to write that down for future use, but if we give it a little bit more heat, what I think you're going to see is this just disappear. Yeah. Not a material I would recommend if it's in a situation where it potentially could catch on fire or be around fire, not only because it doesn't hold up super well, but because those fumes, and mainly the last thing you want is molten plastic dripping onto your skin, because I don't even need to explain that. It flows very quickly. That got annihilated quickly. Not very scientific, but how long it's going to take until this just folds in half from the heat. That was 13.75. That was 13.75. But that's where the self-extinguishing thing comes in. Besides the fact that molten plastic can melt onto you, I mean, this does much better than a lot of other materials, but say you're in the cab of your car, something catches on fire, you do not want to be stuck with those super noxious fumes. And that's where the time to extinguish really comes into play, because that was a lot of smoke. I'll talk you through my thought process here. Nylon, for the low temp world, it's great. It's a miracle material. Nylon is everywhere. I would use this particular material for appearance. Say if I were to 3D print some AC vents in my car and I wanted it to look damn nice and be rugged, being exposed to heat and UV. It'd be great for interior trim pieces because it is a very beautiful product. Interior replacement parts for my vehicle that you just can't find anymore. This is pristine, it's awesome, and it's beautiful. You won't have to do any post-processing with it. The conclusion I have from using this, because to be honest with you, I don't use this stuff a lot because I use the actual PA6+CF Gen 3 is what I tend to use from 3DX Tech. Why do we say 3DX Tech all the time? Are we sponsored? No, it's just consistently excellent products throughout the filament range and and made in the USA. That's huge. My overview for this material is if you are concerned about the appearance of the material, how this part is going to look printed, this is a wonderful material. In terms of durability, under hood, I don't know if I would trust this as much, but we'll have to find out. Maybe I'm full of it. We'll see when we test it. So my takeaways from this is absolutely beautiful printing material, still pretty strong. My gut tells me it's not necessarily as strong as some other PA6+CFs or GFs that I've used before, but it's definitely prettier. So if you're looking for a material that's damn near end-use quality visually, this is fantastic for you. If you're going to be using this in a situation that's actually going to undergo a huge amount of physical stress or heat cycling, you might want to up the material a little bit and head towards a PSU, PPS, so on and so forth. Not a super material by any means. It's a nylon. It's a pretty looking nylon that will save you a lot of money if you're using Markforged. It's better than Onyx. Technically, according to the data sheet, So let's go over to the UTM and actually see what values it gets to see if that's the case. This is going to be Z-axis. That means printed up and down on the bed. I'm actually quite unsure about how this is going to do. It looked like it was printed pretty hot, so I'm guessing this is very strong. Boom, that was fast. Okay. Now earlier in the video I was talking about how this is just a nylon, and I didn't want to come across as talking down on nylon. Nylon is a miracle material. It is used everywhere you can imagine. It kind of changed the world. So infusing it with carbon fiber just makes it better. In about the 10 years we've been using nylon, we've seen it come an incredibly long way. And that's because of different additives, techniques for printing it. So that's how we're getting these pretty remarkable values in terms of strength. I'm personally quite impressed with the strength of the Z-axis on these parts. The other thing of note is printing these Z-axis specimens is usually a nightmare, especially with high-temp materials. Nylon, it's no problem. Let's do a torsion test, shall we? Look at these parts. I'm going to stick one end of this in a vise, and I'm going to use a digital torque gauge on a socket wrench and see how many newtons it takes before these guys fail and how they fail. Here we go, torsion test. .5 Newton meters. Again. Yo, that one exploded. 9.7. Very interesting break. We'll look at that under a microscope, but half of it just flung off into space. That's the way you want to see a part fail. This was very isometric braking, meaning it wasn't just along the layer lines. That's a cool shear. That's my favorite part so far. This is the result of the torsion test using the Obsidian. I cannot think of a more beautiful break. The way in which this torsion test broke indicates excellent printing parameters, overall strength. I guess you'd call it isometric, but you're not seeing it break along a specific layer line. There's no one weak point in this print.
Yeah, isotropic. So in FDM 3D printing, everybody knows, oh yeah, but your Z adhesion is going to be worse and it's going to be, weak along the layer lines. But when we see breaks like this, it's indicative of a very, very good layer welding, layer bonding, layer adhesion, generating basically isotropic-like strength. Isotropic being strong in every direction, the same strength in every direction. Normally you'd be at about 40 to 70% of the strength in the Z.
If it weren't printed properly, you'd see it break usually along a layer line or something, correct? You wouldn't see it break. These are printed up and down, so it's all Z. It broke laterally instead of...
I mean, yeah, you can see it going straight down the layer lines there, and when you look in there, you're not seeing any layers.
For an engineering grade material, I found this to be a very easy material to use. Your default settings will pretty much work just fine, I found, as long as it's dried. This was properly dried, and it printed very well. I'm overall very impressed.
Let's check out the Z.
Let's check out the Z. Now, this is where we'll get some interesting data. So did that break in the middle of a layer? That didn't break along a layer line. If that's 0.2 layer height, some of it sheared in the middle of a layer, but overall it was, yeah, at a layer interface, which of course it would be, given that this was printed in the Z-axis, straight up and down. It brought some of the other layer with it. So I'm actually overall quite impressed. I think the numbers were impressive as well. This is a damn good material.
On that note, do you guys want to see full on how strong can we print it in the Z-axis video with the UTM?
Yeah, tune it just to see how far we can go. Might as well look at the melt.
Oh yeah.
Oh. So the one thing that this did do, it liked to drip almost instantly. The nylon absolutely melts, and it likes to, I got drips right here. Maybe not the best material for use somewhere that there could be a fire, because you don't want that dripping on you. Forget Vision Miner, say you were had a business and you were manufacturing some parts that you designed, I would absolutely use this material as an end use. If I didn't have access to SLS or SLA, this is the closest thing to having an end use part in terms of appearance, overall finish
100%.
quality, because you don't want to send out a part that looks very clearly 3D printed.
Right. Well, and still having that quality or the mechanical properties of CF-nylon, but beautiful parts. It's a no-brainer.
Overall, we should give it I'll give it a Cole score. 0 out of 10. I would give this material an 8. And going into this, I don't think I would have. I would have thought I would give it a 5, but it's impressed me in almost every regard except fire. Let me add one thing here. This is just the very beginning of this series, and what I mean by that is we're already getting a lot of useful and entertaining information, but we have probably another 10 tests that we're going to start incorporating into these videos to go into extreme detail. So if there's any specific tests you'd like to see or see us torture a material in any specific way, leave your comments down below. We read all of them and we want to engage with, our viewers. So personally, from my heart, thank you so much for watching. Thank you for being subscribed and thank you for interacting with us. I've learned just as much from you guys as you might learn from us. Rob?
Thanks for watching. Have a positive rest of your day. We'll see you on the next video.
I love you. Thank you guys for tuning in and watching. Stay tuned next time for our next material, which is going to be... Is it? Oh man, you guys need to subscribe because guess what we're doing next? Your favorite, my least favorite, peak coming next time. Subscribe. Thanks guys.